Well, here we have two of the engineers of the SS Master. They got Jack Dixon, also of the Pacific Yellowfin, and Doug Shaw, our chief engineer.
Okay, the gauges here are displaying the pressure on the various parts of the engine room. That, of course, is a clock that tells you when it's time to go for coffee. This one is the pressure gauge, showing the 165 pounds per square inch pressure in the boiler at the present moment. This is the pressure gauge showing you what the fuel pump would be pumping into the furnace burners. This one is showing you the pressure of steam which is being used to drive the burner pump. And this is the temperature at which you're putting the fuel in there. At the moment we don't use that because we're burning diesel oil and we don't need to heat it. This one shows you the pressure that's going into the steering engine to steer the ship. This is the pump, this is the gauge that would be showing you the pressure if we were using the electric fuel pump to drive the burners. This is the generator engine which was always used at night to light the ship. During the day they would have a bank of batteries which had been charged up overnight, and what power they needed would be supplied from the batteries. We don't do quite the same as they did then, but it still is the generator. The engine is a genuine General Electric steam generator engine. The generator, which may or may not be original, is a DC generator that provides 5 kilowatts of 110 volt DC power when you turn the engine at 625 revs. That's all the power that the ship would need in those days. There was very little electrical on the ship then, and there's very little electrical on the ship now, for that matter. We don't have too many modern gadgets aboard. We have tried to restore this boat to the state it was in about 1927, which is as far back as we have any records of her. And we don't need power to drive the ship. No electrical power, no electrical steering, no electrical anything else for that matter, other than the radios and the radar, which are now run from batteries. Well, as we said, this is a triple expansion steam engine. Double acting, which really doesn't need to be said because they all should be double acting. The high pressure cylinder gets steam from the boiler at 175 pounds into a 9.5 inch diameter cylinder. You allow it to expand in that cylinder, and when it comes out there should be 30 or 35 pounds maybe pressure in that boiler. It goes into the the medium pressure cylinder, goes into the medium pressure cylinder, which is 16.5 inches diameter, and expands in there by pushing the piston up or pushing the piston down. When it comes out of there, there may be 5 pounds or at the most 10 pounds of pressure left in it. Goes into the low pressure 26 inch diameter cylinder and expands in there. When it comes out of there, it should be under 22 inches of vacuum, because there is a condenser built into the back, seawater cooled, which is turning the exhaust steam back into water so it can be pumped into a hot well and then pumped back into the boiler. The engine direction is controlled by the Stevenson link gear, one to each cylinder. In its present position, the head link and eccentric will be in effect, controlling the valves so that when you apply steam, the engine goes in the ahead direction. To go astern, you have to stop the engine, use the reversing gear, and this ahead link comes out of position, and the astern link goes into position, so that when you apply steam again, the engine turns in the opposite direction. And bear in mind that when this engine's turning, so is the propeller. There is no reduction gear, no clutch, no gearbox. When this engine turns, the 8-foot diameter, 9'6" pitch propeller is turning at the same time and at the same rate, which is normally 100 to possibly 105 revolutions a minute. The engine was designed to run at 135 revs per minute, but we don't usually go at that speed. We want to keep this engine as long as possible, and we treat it as gently as possible.
How many miles is this engine steamed?
When the ship was in service, it's calculated that she's done well over 1 million miles. How many it's done since then, I don't know. She was retired from service in 1959, and from 1962 onwards, there are various organisations have spent their time restoring the vessel, and where the vessel cost approximately $34,000 to build in 1922, it was calculated that by 1986, when the ship went to Expo, at least $500,000 had been poured into the restoration of her. I would not be in the least surprised if somewhere near another $500,000 hasn't gone into her since. And she's still sadly in need of assistance. We have all kinds of work to do. The watertight hull built from the waterline down is good, but everything else, the bulwarks, the stern, the counter, just about everything you name is still in need of work. And what we need is someone who can sponsor the vessel to allow us to continue the work that we've been trying to do over the years. Whether we'll get that or not, I don't know. If we don't, then there won't be a ship.